and we'll see. So today's section is 1D. Find a quadratic from its graph.
1D?
Yes, I know. I've been secretly thinking that all day. Okay.
What's 1D?
One Direction, dude.
Get that out of me.
All right. Keep in mind, I'm trying to record this for the website, so let's stay focused.
Wow, Julia.
All right.
Who's saying get that out
So-
of me?
Stop box. Back to regularly scheduled programming here. Find a quadratic from its graph. So we spent pretty much the rest of this week, we were working on graphing and how we can take an equation and graph it. We're going to be doing that in reverse today. So that's pretty much what this next slide says. We're going to use it in reverse. So I'm going to write some stuff on the whiteboard so that we can keep it up the entire time as we go through these notes. So there were a few different general forms we worked with. Does anyone remember any of those general forms with the P's, the H's, K's, Q's, all that? You got one of them? You got one, Laura? Maybe? No? Gabby, you got one? Try it? You want to just try it? I can fix it. Tony, you got one?
Just y equals a, and then in parentheses x minus h plus kf without type parentheses, if that makes sense.
Yeah, that was one of them.
Oh yeah, and it's squared. Thank you.
That was absolutely one of them. We gotta fix that K. That's not gonna last there. Okay, get another one. Okay, I'm gonna change something. We're gonna be minus. But yes, we got x minus p and x minus q. Another really important one. We got another one, Alex?
The y equals ax squared plus bx or plus c.
Kind of like our general standard form. Hannah, you got the last one?
Y equals a parentheses x minus h squared.
Very good. So we are going to be using these. We were going to talk about standard form, but we're going to mainly focus on these first three here. And one of the most important things is to pick out which one to use. So when we've got intercepts, and I'm going to go over this again and again and again in our examples, but we've got two intercepts. We've got P and Q. If I touch the graph just once, I'm going to go with the x minus h. If I know the vertex, I'm going to go with h and k. So part of it is picking out which form we want to use. So here's our first example. We're going to hit hard with examples today, but again, I don't think it'll take us too long. So you want to find the equation of the quadratic with this graph. And so again, taking a look at that graph, we want to look at some of those key features and figure out which one of these equations to use. Right away, what I notice is that I have two intercepts. That's going to be P and Q. So I want to use y equals a times x minus p, x minus q. Does that make sense how I picked that one out because I had the intercepts? So the first thing I can do is I can just put those values in for Gesundheit, P and Q. So I have x minus negative 2 and x minus 1. Absolutely. We definitely want to take that double negative and make it into a plus. So I have y equals a times x plus 2, x minus 1. And you might find yourself even skipping that first step if you feel really comfortable with those negatives, that's fine. The next really important piece is we need to figure out what a is. We know a is so important. It tells us if it's going up and down. It tells us if it's going to be narrower or wider. And speaking of up and down, since I'm pointing down, what do I know about my a value? Yes. And I was real off. No, I was real off. I don't know how many mistakes I made in second hour, just very, very simple ones. But one of them was I dropped a negative. And I came out with an a being a positive number. But I knew it was wrong because my graph was pointed down. So keeping that in mind will just help you out for those little mistakes that happen. Now, I also have 4 here as my y-intercept right there. And so I know that's going to be at 0, 4. And I can use that information and plug that in my x and my y spot. So I've got another point that's on my parabola. I've got a point there at 0, 4, so I can plug that in. So I'll have 4 equals a, 0 plus 2, and 0 minus 1. So you guys can keep evaluating that and try to figure out what a is. Don't shout it out so no one can think. So once we figure out that a is -2 after adding, subtracting, multiplying, and dividing, I can go ahead and plug that back in. So my answer is y equals -2 times x plus 2 times x minus 1. Okay, which piece?
Why do you add them like at the
Right
first? Yeah, and not why don't?
Because I can simplify it because these are just numbers without any variables in it.
Yeah.
Like if it's a variable in it, then I can go about that foiling stuff, and we will actually see a situation that has that on it later. But since it's just numbers, I can just follow my order of operations and simplify what's in the parentheses. Any other questions? All right. So here I've got a graph. My directions are still the same. I notice that it is pointing upwards. Yep, it will have to be positive. So since I only touched that x-axis one time, I do want to use the equation that just has that h. So y equals a times x minus h squared. And that's kind of nice. This, where I touch the x-axis, that goes in my h spot. I just have to put that where the h is. Once again, you might kind of skip that step and make it positive right away. Then, in a very similar fashion, I'm once again crossing the x-axis, so I've got another point that's on my parabola, and my point here is at 0, 3, so I can plug that in for x and y in order to find a. Most of these examples, not all of these, but most of these, the point that we are using is the y-intercept, but it doesn't have to be. It could be any point that we have that's on the parabola. So 0 plus 1 is 1, and 1 squared is just 1. So my a equals 3. Gotta plug that in to write my equation. So y equals 3, x plus 1 squared. Coming up with any questions so far? Concerns? So we're going to keep kind of looking at different situations that you guys might come across. When you rewrite that? All right, so we've got another one, and I forgot to, when I made this, I forgot to put this 4 on my picture, so that's supposed to be there. we're gonna figure that out. Good observation. So I've got two intercepts, though I don't know what one of them is. But the fact that I've got two intercepts means P and Q. So when you're crossing that x twice and you've got those numbers there, well, and we can figure that one out, we're going to use y equals a times x minus p, x minus q. And you might not need to write that down every time either. Like I keep writing them down so you keep seeing them and you know where we're going with stuff. So I'm going to go through it, okay? I'm going to go through it. Now that line down the middle is the axis of symmetry. It's exactly down the middle. So each side is like a reflection. So if I take a look, if I've got an intercept at -2, I can figure out how far away it is from the axis of symmetry. Because I'm starting at 1, going to 0, to 1, -1 to -2. That's 3 units away. So we can count that out. And I know this doesn't have all like the tick marks, like I know sometimes we're used to those graphs, but we can still count that out from 1 to -2. And then that means that the distance on the other side will be exactly the same. It'll be 3, so I can count that out. 1, from 1 I've got 2, 3, 4. So my other intercept is 4. So I can put -2 and 4 in for P and Q. Have any questions? We still got to keep doing that same thing. I bet you already know what I'm going to do next. Plug in that y-intercept to figure out what A is. So we've got 0, 4. I think there is a way that we could have done it without that, but it's a little easier with that number right there. Did you guys already do it? Am I too slow? Yeah? Oh, I cannot tell with you if I'm being too slow or too fast. Sorry. I do want to pause right here because so many people make a really small mistake right here and they say that A is -2. A is not -2. So just make sure you take your time with that, because when we divide both sides by -8, we've got 4 over -8, so it's actually -1/2. And that kind of makes sense. I mean, it has to be negative, so it's, concave down, and it's a little bit wider than some of those other ones. No, I was estimating when I graphed these, but kind of makes sense there. So -1/2, x plus 2, and x minus 4. All right. Got another picture we're going to go for. Are we all good?
The next one, the last one?
No.
No?
No,
What
it's
about
not. Okay. So we've got something that's open and down. We've got an axis of symmetry on it. And notice it's crossing just once, so I'm going to use the x minus h squared. The thing is I can see I'm crossing once, but I don't really have a value there. So how can I figure out what that value is? You got an idea?
The axis of symmetry doesn't that go through the vertex?
Yep, the axis of symmetry is going right through that vertex. So if this is x equals 2, that's going to be 2. So keep that in mind, that axis of symmetry, the number for that is the same as that h. So I can plug in 2 for h. And And then we can go ahead and plug in 0, -6 to find out what A is. When I do 0 -2, I get -2. I square it, I get a +4. This is the one I made a mistake on. I actually wrote down a -4 and threw everything off. But then when I divide by 4, I end up with -3/2 equals 8. So I can plug that in. So I have y equals -3/2 times x minus 2 squared. The next one we're going to do is a word problem. So we're not going to have a picture. We're going to have to still kind of figure out where to go from there. Are there questions or concerns so far? No. Okay, so this one's got kind of a lot going on, and this is where that general form is sort of sneaking its way in there. So it says, find in the form y equals ax squared plus bx plus c, the equation of the quadratic whose graph cuts the x-axis at 1 and 3 and passes through 4, -6.
That's
Good. My glasses, I need new ones, I guess. 4, 6. So here's the deal. What this means is that this is what our answer should look like. But that form is not going to help us get the answer. So we still need to stick with one of these 3. And then we'll end up moving around our answer so it looks like this. Yeah! I love it. You guys are catching on. We see we've got 2 intercepts. So we're going to use those for P and Q. So now we don't have an intercept, but we do have another point, and that's why I mentioned it earlier. You don't always have an intercept, even though that was really heavy on the other examples. But I have a point that's on there, so I can plug that in for x and y. It's on my parabola. So once we get that far, we can plug that in. It's just that we're not done quite yet. So we definitely did stuff just like this on like our background knowledge section, but you're going to want to FOIL that and then times that by 2. And you technically you could distribute the 2 first and then FOIL. So there are other ways we can use that commutative property, but I'm going to FOIL first. And some of you might do that step in your head as well. So then once you've got that all FOILed, you do have to multiply every single piece by 2. So just pay attention. If it does say to put it in a certain order, or like a certain form, then you should do it. We're going to have a stop box and have one last example. Are there questions, concerns, things you're unsure about? three different forms of quadratic functions that you can use, or there are three different forms. So what are they? And I know we've only used two so far. We are going to hit up that last one in the last example. But write these three things in your stat box so that when you look back, you see those three equations. And then the general form is just to remind ourselves that sometimes we do have y equals ax squared plus bx plus c. So you can always get those off the board. Here is our last example. So it says, if v is the vertex, then find the graph of the equation of the quadratic function, find the equation of the quadratic function with this graph. So vertex is when we have that h and k that should stick out to us, so we're going to use y equals a times x minus h squared plus k. And those values for our vertex, 4 and negative 6, will be what we put in the h spot and the k spot. Now we don't have a y-intercept on this picture, but what can I plug in for x and y? Well, we plugged in h and k. Yeah, that's 7. So that's at 7, 0, because it's an x-intercept. So we'll plug those into x and y. So I end up with 6/9 equals a, but what could I reduce 6/9 to be? Yeah, 2/3. So then I just have y equals 2/3 x minus 4 squared minus 6. That's it. So we'll get that assignment up in a second. Any questions or concerns? Anything you're like,